All right, what's up, guys? In this video, we're going to pick up with some differential equations, and we're going to solve a first-order linear ordinary differential equation using integrating factor. So the first thing I want to do is discuss the form of a first-order linear differential equation. So a first-order linear differential equation will take the following form. It'll take the form dy over dx plus p of xy is equal to q of x. Some people also write it as y prime of x plus p of xy is equal to q of x. So you may see it written either one of those ways, so I just want to make you aware of how it's written. And so basically what you do to solve or to find a general solution to this type of equation, there's about 4 steps, and students typically hate solving the first order linear ODEs, not because it's hard. I don't think it's difficult, although that can vary student to student, but it's not as easy as the separable equations, because remember, for the separable equations, we just need to separate the variables and integrate both sides. Even if we have an initial condition, which is just where we solve for the constant, there really isn't a whole bunch of work to do with some of those separable equations that you start with. But the linear first order ODEs, especially when you use an integrating factor, it's a bit of a process. So that's why most students don't like it. So clearly, if we look at what we're given here, y prime minus 2y is equal to x squared, it's not in the correct form, so we need to make sure we get it in the correct form. So the first thing we can do is start by dividing everything by x. So we'll have x times y prime, we'll divide that by x, and then we'll have minus 2y, we'll divide that by x, and then we'll have x squared, and we'll divide that by x as well. And then simplifying, this just gives us y prime minus 2y all over x is equal to x, or let me write that better than that. It's going to be y prime minus 2y over x is equal to x. I wanted to make it a little bit more neat. So that's the first thing, to make sure it's in the correct form. The next thing we need to do is identify what our p of x is, and identify what our q of x is. So what's our p of x in this particular case? Well, our p of x here is just negative 2 over x, and our q of x here is just simply x. Now, the way that we find the integrating factor is very simple. All right, so for the integrating factor, remember that's just e raised to the integral of p of x dx. So in our case, that's just e raised to the integral of negative 2 over x, all integrated with respect to x. And then this will obviously just give us 1 over positive x squared, or 1 over x squared. And that would be our integrating factor. So I'm going to denote integrating factor IF here just for a second. And just imagine IF stands for integrating factor, and our integrating factor here is 1 over x squared. That's the integrating factor. The next step is to multiply the differential, everything in the equation, by the integrating factor. So we'll have y prime multiplied by our integrating factor, 1 over x squared. And then we'll have minus 2 over x y, multiply that by 1 over x squared. And then over here, we'll have x multiplied by 1 over x squared. Now what we do is we, of course, simplify, apply the product rule on this side, and integrate that side. So let's get another sheet. So when we simplify this side over here and apply the product rule, we'll simply get 1 over x squared multiplied by y, and then we'll need to integrate the other side. So we got x times 1 over x squared, which is just 1 over x. So we're going to need to integrate 1 over x with respect to x. So we know that the antiderivative of 1 over x dx It's technically ln absolute value of x plus c, but in this case, we'll just write it as ln of x plus c. So now what we do is we connect our left-hand side here, which is 1 over x squared multiplied by y, and that's just going to be equal to this side over here, which was ln of x plus c. We need to isolate the y, so what we need to do is we need to multiply both sides of this equation by x squared. So that's what you want to do next. So multiply both sides by x squared. Okay. And if we do that, we'll get y is equal to, well, it looks like we're going to get x squared multiplied by ln of x. One other thing that's very important that a lot of students forget about, when we're multiplying both sides of this equation by x squared, that includes multiplying it by the constant. So this becomes plus x squared c. And that's the general solution and the final answer. So the final answer for this our general solution is just simply going to be y is equal to x squared multiplied by ln of x plus x squared times c. That's the general solution. That's the answer. So I hadn't posted a linear first order ODE in a while, so I thought I'd post an example of solving one of those or finding the general solution. So hopefully that made sense. Again, it is a bit of a process to get used to, but with some practice, you should be able to catch on to it. All right, that's going to be it for this video, guys. I'll see y'all next time.